Welcome to the introduction to parallel circuits. My name is Josh Hill and I will be your instructor. For the purposes of this video, we're going to follow electron flow around this parallel circuit. As a review, we're going to go over the three laws that are going to apply to parallel circuits. Each one of these laws has a formula that's associated with it. Kirchhoff's voltage law states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop, which is also zero. In other words, the algebraic sum of all the voltages within the loop must equal zero. Interestingly enough, when you look at a parallel circuit, those loops are all in parallel with each other. And thus we see that the voltage across each branch is actually equal to the source voltage. Now we will move on to Kirchhoff's current law, which states that for a parallel path, the total current entering a circuit's junction is exactly equal to the total current leaving that same junction and or node, because it has no other place to go. Therefore, I total is equal to I1 plus I2 plus I3. If our I1 is 4.8 and our I2 is 2.4, our I3 also being 2.4, then we will have an I total of 9.6. Now we will shift to resistance. We will have one 5 ohm resistor and two 10 ohm resistors. One thing that we will find is that the total resistance in a parallel circuit is always less than any of the branch circuit resistances, and we'll be using this formula. R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So we will take those values of 5, 10, and 10 and plug it into the formula and get a total resistance of 2.5 ohms. And thus we see that our total resistance is lower than any one of the other resistors in our circuit. And thus we see that the voltage across any one of the branch circuits is equal to the source voltage, knowing that our voltage total is equal to V1, equal to V2, and equal to V3. We also see that our I total is equal to the summative value of the current in each one of the branch circuits. I total equaling I1 plus I2 plus I3. Or in other words, that the current that enters a node is the same value of the current that leaves the node. Lastly, we see that our total ohmic value is less than any individual ohmic value in a parallel circuit. Thanks for watching. I hope this video was informative and helpful.